Okay, we're going to start with section 4.2, translations and of the sine and cosine functions. Now this involves algebra. So let's take a little aside here and make sure you can remember. And we're talking about horizontal and vertical shifts. Okay, so let's look at a parent function from algebra. And we're going to use our calculator. So we have the parent function y equals x squared. We know it's a parabola. And we know it has a vertex. And that's mainly what we know. And it looks like this, where the vertex is 0, 0, and it's also the x and y intercepts. So we're going to use our calculator. Don't worry if you don't know anything, because we're just going to follow along. Here we go. We're going to hit the y equals, and you're going to clear any stuff you have in there. Okay, all right, so we're good. And I'm going to enter the x variable is 1, 2, 2, 2, second row, second key, x. And then we're going to hit the x squared. And then we want the window to be a 10 by 10. So we're going to go zoom number 6, standard, Z standard. That means the window is a 10 by 10. And there we go. So we see this sky. Now we know if we add something to it, if we add a value after the variable, we get a vertical shift, up or down. Up if positive, down if negative. So let's do that. So we're going to go to the y equals, and we want to move it up. So we're taking the parent function, and we're entering second row, second key, x squared, and we're going to add 2. And we're going to graph it. Hit the graph key at the end of that connection. So we can see that it moved up 2. Nothing else changed except it's plus 2 to every ordered pair. Every ordered pair. Well, so now what we want to do, so we did in y1 x squared. On y2 we had x squared plus 2, and it moved up 2. So we're talking about a vertical shift, because it's away from the variable. Now let's do y's of 3, and we're going to do x squared minus 2. So this should be what? Down 2, and it's also a vertical shift because it's not attached to x. All right, so we're going to go to y equals, and we're going to go to y3 and do our second row, second key, x squared minus 2. And we're going to graph it. And there it is. It's below the x-axis. Okay. So now we know that if a number is added or subtracted from the variable, it is a vertical shift. All right. Well, what happens if we attach a value to the variable with parentheses? All right, so let's go to our y equals. Go down to y2 and clear it. Go down to y3 and clear it. So on y2, we're going to do open parenthesis x plus 2 squared. Okay, make sure you get your square. All right, so now we're going to graph it. There's our parent, and look. So if we have y1 equal to x squared and y2 equal to x plus 2 squared, the parabola moved 2 places to the left of origin, right? So it was opposite sign, direction. So we can see that. Well, what if we do y sub 3 and we do x minus 2 squared? Can you guess? We're guessing the parabola moves 2 places to the right of origin. And that's because of that opposite sign direction. All right, well, let's figure it out. So we go here. We're going to go to the y3, enter open parenthesis, which is above the numbers, x, second row, second key, minus the 2, close parenthesis, and the x squared. Everybody got that? Now remember, you can pause this anytime you choose. And we're going to, well, sure enough, it moved to the right 2. To the right 2. All right, so we're correct. Now, what this action was called is if a number is attached to variable by addition or subtraction, the parabola moves on x-axis in the opposite sign. Of value. Okay, and this is called a horizontal shift. All right, so we did vertical shift and horizontal shift because we are going to do this with trig functions. So we're going to say our horizontal and vertical transformations of sine and cosine trig functions. So we'll apply the algebra knowledge to the trig functions. With same rules as above. All right. And we'll do it to where you'll get the information. All right. So here we have the position of y equals sine x minus d in parentheses. If change is in parentheses, we have a horizontal shift. All right. So here we know we have the graph y equals sine x plus 2. And we're going to do the math. And in this case, we still have this argument. So in our argument, we're going to convert the quadrantals to help plot a period of this function. All right. So our first step. Find the new values, I should say radian values. That create the quadrantals. So we're going to set argument equal to quadrantal. All right. So I have x plus pi halves equal 0. So I'm going to subtract the pi halves. So then that gives me x equals negative pi halves. This is my first quadrantal. So we're moving it to the left. We know that. It's a phase shift, a horizontal phase shift. To left. Pi halves. All right, we know that. So, and that one proves it. So let's do our second one. X plus pi halves has to equal pi halves. So I'm going to subtract pi halves from both sides of the equation. X equals 0. So this is my second entry. All right, so I'm good to go. Good to go. Now I'm going to do the third one. I'm going to have x plus pi halves is equal to pi. So I'm going to subtract pi halves. So x equals, now remember, I have 2 pi halves, which is the same as pi. Minus pi halves, I get pi halves. All right, so we're good. Just in case you didn't recognize the math, the common denominator. So I have my third one, and I'm looking at my fourth one. X plus pi halves equals pi thirds. 3 pi thirds, sorry about that. Three pi halves. So I'm going to subtract the pi halves. When I do that, I have x equals 2 pi halves, which equals 2 pi. So now I have my next one, and now I'm doing my last one. X plus pi halves is equal to 2 pi. So I'm going to subtract the pi halves, and that gives me x equals 3 pi halves. All right, so you notice that we're moving to the left pi halves. All right, so now we're going to do our t-chart. And we don't have an amplitude or a change of period. We will eventually, but not right now. Okay, so in my t-chart, x is a negative pi halves. So we're going to have, our y is going to be sine. And we're going to have negative pi halves plus pi halves. So we're going to have sine of 0, which is 0. So negative pi halves, 0. Then we're going to have um, 0. So sine of 0 plus pi halves is sine pi halves, which is 1. So then I'm going to have pi halves. So I'm going to have the sine of pi halves plus pi halves. That's going to give me the sine of pi. 2 halves make a whole. And I'm going to have 0. Then I'm going to have 3 pi halves. And that'll give me sine of 3 pi halves plus pi halves. I'm sorry, I skipped one. I should have been pi. Sorry about that. I did the last one first. Sorry. So I'm going to have pi. So that makes it sine of 3 pi halves. Now you see that I've got the quadrantals right here. So that's going to give me -1, and then my last one is 3 pi halves. That's going to be sine of 2 pi, and that's going to give me 0. There you have it. So now we want to plot those points. Negative pi half and 0 is right there. 0 and 1, and we're going to make this 1. Then we're going to have pi halves and 0. Then we're going to have pi and -1. Then we're going to have 3 pi halves and 0. And there we have a perfect sine curve. Shifted to left. Pi halves amount. All right. And of course, we could draw further, but we just need one period. And your curve will happen on the item. Now, let's see what pi halves would have been. Well, pi, the normal, the parent, would be like this. And you can see that it is a shift to the left of that amount. Okay, now they're just asking us to identify from what we know. All right, so what do we know? We know that we have a sign. So we have y equals a sine of bx minus d. They had it as a d. All right, so we have to do math. We cannot just label. So we have to factor out the b. All right, so we know that the amplitude is the absolute value of a, which we have the absolute value of 4, which is 4. Now, when it comes to calculating the period change, all right, we have to factor out 6. So let me write it down. All right. Sorry about that. I thought I had it included. I'm going to factor out the 6. That gives me an x minus 5 over 6. All right. So now I have my b. So we know that the period is 2 pi divided by b. So I'm going to have 2 pi divided by 6 pi thirds. Pi thirds. All right. Now they want the phase shift. All right. Let's do that phase shift. And we know the phase shift is opposite sign direction. So we have x minus 5, 6. So it is to the right 5, 6. And we can do it with our calculator, but let me go ahead and introduce that. All right. And we're going to clear everything. All right. We're going to enter our original function. 4 sine, open parenthesis, it is there, 6, second row, second key, minus the 5. Okay, and we're going to do it manually by window. All right. So in our window, we know that we have a very small period, pi thirds, and we have a shift to the right. So we can start with x min at 0. x max, which is our period, we can do pi thirds. Actually, we need more than that. Let's do pi thirds, and we're moving 5, 6. So let's do pi halves. We're going to do x scale as pi thirds, because that's, I'm pretty sure it's going to be smaller than that, but it will end up in a pi third of some form, plus 5, 6. All right, so then our y min, our amplitude is 4. Let's put -5 and our y max, +5, and our y scale 1. Now, this may or may not work because I'm thinking off the cuff, so I'll go to window. I'm going to put 0. Then I'm going to enter pi halves, second pi divided by 2. On my scale, I'm going to do second pi divided by 3. And then I'm going to do a -4. Oh, I said 5. Hold on. A -5 and a +5 and a scale of 1. So I'm going to graph it. And I can't really see it, but I can totally kind of see it. Oh, wait. Did I enter 4? 4, sine. Oh, I better do trig. Hold on. Let me do trig. Let's do trig, number 7. And now change the window. Sorry about that. So now we're going to do 0, pi halves, and we're going to do our scale is, oh, you know what's wrong? Oh my God. Back up. Oh my gosh. My goodness. Why didn't that go right? Note. Have to change mode to radian. Oh my goodness, that's why it was off. Okay, I got it. So I'm going to go to mode, and I have to now change it to radian. Oh my goodness. Okay, so now I'm going to go to window. I'm going to do what I said, 0, second pi divided by 2. Well, this is good because you saw that the graph was just too yucky. You couldn't even see it. And then we're going to do second pi divided by 3. And we're going to go that way. And we're going to graph it. Look at that. Look how beautiful. Look how beautiful. All right. So we know we had a sine. So sine starts at 0. So we started here, up, and ended here. So we want to know if this is pi thirds, right? Actually, it's going to be, because we shifted it over, it's going to be some kind of value here, which is, we want, what is that? That's equal to pi thirds, so that's +5. Oh, it's a mess. Okay, so we want to know second trace, and we want pi thirds there. So that's going to be 2 pi minus 5, right? And we should, oh, I didn't do good math, but you get it. So I can do a trace. And there it is. Close enough. Come on, up. There it is. Close enough to 0. And that is that action there. So you can see what's going on there. Play with it and figure it out. I did pi thirds because the period was pi thirds. But the period starts here and ends here, so I don't know those end points. All right, so there we have it. All right, so let me put the calculator down, but that gives you an idea. You have to have played with it a lot to get anywhere near what you have. So here we're talking cosine. Cosine is A cosine x minus d. D is the transformation, the horizontal. So be careful when you do your homework which mode you're in. If you're working on chapters 1 through 3, you have to be in degree mode. After that, we're all radian. So let's talk about what we have. Our amplitude is easy. It is 1 because we have a 1 understood in front of cosine. Our phase shift is all we have. It is pi halves to the right because it's opposite sign. All right, so we're going to first calculate our arguments. So we want x minus pi halves to equal 0. I'm going to add pi halves. So x equals pi halves is my first entry for that quadrantal. Then I'm going to have x minus pi halves equals pi halves. I'm going to add pi halves. And I'm going to get x equals pi. Then I'm going to have x minus pi halves equal to pi. So I'm going to add pi halves. So I'm going to have x equals 3 pi halves. Then I'm going to have x minus pi halves equals 3 pi halves. I'm going to add pi halves. And that'll give me x equals 2 pi. And my last one, okay. And it got stuck a little bit, sorry. Okay, just a second. So then I have x minus pi halves is equal to 2 pi. I'm going to add pi halves to both sides. And this gives me x equals, so that would be 5 pi halves. Okay, now I have my values. I'm going to do my t-chart. All right, so I'm going to start first with pi halves. So I have cosine of pi halves minus pi halves. That gives me cosine of 0, which gives me the 1. Then I'm going to have pi. So I'm going to have the cosine of pi minus pi halves. Well, this is going to give me the cosine of pi halves, which gives me 0. Then I'm going to have 3 pi halves, which is going to be cosine of 3 pi halves minus pi halves, which is going to be cosine of pi, which gives me the -1. Then my next one is 2 pi, which is going to be the cosine of 2 pi minus pi halves, which is going to give me the cosine of 3 pi halves, which is going to give me 0. And then I'm going to have the last one, which is 5 pi halves, which is the cosine of 5 pi halves minus pi halves, which gives me cosine of 2 pi, which gives me the 1. All right, so I've got my values, and I'm going to plot them. And I'm starting at pi halves. At pi halves, I have, this is my 1. At pi, I have 0. At 3 pi halves, I have -1. And then at 3 pi halves, at 2 pi, I have 0. And then I don't have my scale correct, but then I have the 1 over here at 5 pi halves. So I have this. And I have my bowl. There you go. And we can do it on the calculator, because this one is easier than the first one I did. So we want to erase what we have there. And the function on this one is cosine. And I'm going to have x, which is second row, second key, minus pi halves. Oh, sorry. Oh, let me clear that. Let me do it again. Cosine, I'm going to have x minus, oh, I hit alpha, didn't I? I want that one. That's what happened. I wondered what happened. Divided by 2. All right, pi halves divided by 2. And on my window, I'm going to have the 0. And then on the next one, I want to have 5 pi divided by 2, because that's the end parameter. And I'm going to have pi halves. And I'm going to have a -2 and a +2. And I'm going to graph it. And there it is. Okay, now we know we have a cosine. So the cosine starts, second calc value, and it starts at pi halves. And you'll see that's where it is. And it ends at 5 pi, because we have the bowl. Then it's going to end at 5, value, second pi, oh, sorry, graph. I'm going to do second calc value, and I'm going to do 5 pi divided by 2, and I get that in extremity, and there you have it. So that was a good one to do on the calculator. All right, so now they want us to identify the amplitude, the period, and the phase shift. So the amplitude is easy. We know that y equals a cosine b parenthesis x minus d. All right, because we have to factor that out. So the amplitude is a equals 4. And that's what it is, because it's positive. The period, we have to do the math. So let's do that. So I'm going to have y equals 4 cosine bracket. I'm going to factor out the 7, x minus 6/7. So it is the period is 2 pi divided by b, which gives me 2 pi divided by 7. And that's my period. And then the phase shift. It is added to it. So it is a shift of the function to the right 6/7. All right. So here are the constructions of what I just did, and you need to put these two in your notes. C is the vertical shift. A is the amplitude. B is the period change. And amplitude is the absolute value. And period change is 2 pi divided by that B value. And D is the horizontal phase shift in opposite direction, in opposite sign direction. Okay, now that's as good as I can get it. Okay, I'm going to stop right there because it's very long. Thank you for listening.